Good morning, ladies and gentlemen. Thank you for coming so early in the morning. My name is Guillaume. I'm a Mandriva contributor, and I will be talking about one of the open source projects I'm involved in, which is called youri. That's a base outline of the talk. I will first talk about the motivation that led to the project. Then I will talk about the project itself, what it is, and try to draw some conclusion about my experience I had with it. So, the motivations. When you're involved and when you run a package distribution task, you get many things to do in order to make the project work. First, you have to ensure that package creation gets well, meaning you have to set up some kind of build infrastructure with build hosts, build bot, whatever, and then you have to get some kind of submission procedure that new package gets added to the repository. That then you have to ensure that your package repository gets distributed worldwide, meaning you have to create indexes for a meta package installer. You have to ensure that your mirror gets synchronized correctly, and then you have to check, or that's mandatory part, but if you're a good maintainer, you have to check that your package works correctly, meaning you have to perform some kind of basic quality assurance tests and eventually listen what your user thinks of what you do, if you care, of course. So that's basically a lot of stuff to do. In order to do this various tasks, you get many tools already available. For package checking, for instance, you get rpm-lint for rpm package, and Debian World you get Lintian. For indexing your package, you have additional tools such as create repo, which creates yum indexes. You have rpm to HTML that translates a package repository to a set of HTML page and so on. And for tracking your problems, you get some different kind of bug tracking systems, such as Budzilla retrostructure. What is missing is the glue between all those different paths. So you need, unless you love to do everything by hand, you need to automate and to integrate all this stuff together. I've been personally involved in several projects. I always am a modular contributor, but I'm a simple member. But as I've been a founding member of two different packaging projects, which are PLF and Gpackage, and I was both founding member and the sysadmin for the machine running those projects. So I had many things to do. The first attempt to glue all these different tools was to use adult scripts, as usual, shell scripts, and it was quite ugly. The implementation used different kind of script. There was spell script, shell script, anything, and it was very dedicated. There is one set of scripts for PLF project, one set of scripts for Gpackage project, and in Mandriva world it was even worse. So, what are the limits of this kind of approach? Was if you have different projects, you have different policies. The structure of repository change. Some projects have a very deep project with branch, release, whatever. So you end up having different tools, and you can design one tools for one project and adapt to other. It's at the beginning it's possible, and then very quickly they diverge, and you can't compare them anymore. And when you fit one, you have to fit the second. That's kind of problem. So the problem is diversity. Different projects have different needs. So how do you handle those needs? One possibility is to adapt yourself to the superset of all needs. You got one tools to do everything, and that's painful to maintain. You can't. And as soon you correct something for the need of one project, it has side effect on the other. That's Impossible. Although you can have the subset of the shared needs, and then you got a minimal tool or a minimal set of tools that do only a minimal set of tasks. So you can have something that upload a package from one place to one place, but then you have to manually run it on each project to give it correct argument, for instance. So from this past experience of gluing tools with add-on scripts came the idea of having a dedicated project which will allow to glue things perfectly without limits. It was the youri project, which is, as usual, word-rich, which means youri offer an upload and repository infrastructure. What a nice definition. So what is it? Basically, it's Perl stuff. And you Perl modules and generic engines. What is not? It's not something that is ready to fill your needs. Basically, it's developer targeted, and you have to program the path that will address your exact needs. And the design goal, there was some design purpose. I will wanted to have something that was very versatile, which was package format independent, something that will work with both RPM on Debian package, for instance, and whatever else, which will not impose to use some process tool. Would like to use either kind of bug tracking system, any kind of versioning system, whatever. That will not impose policy, meaning that policy were not were up to project administrators and not to the tool designers, and will not impose a structure and a package repository structure. Something that will be modular, using plugins, of course, and something that will allow easy kind of delegation. When you run a packaging project with many people involved, there are different roles. There are people that are admins for the project, and there are maintainers for the various package. And if all exception, for instance, because if you have a policy that your package should not do something very, very ugly, for instance, you always have exceptions. For instance, in RPM lints, there are kind of exceptions about permissions and which binary files will be allowed to be set to ID or set to ID, for instance. And if you manage all the exceptions and you centralize them in the tools, the guy that maintain the tools itself will be the one that prevents scalability. The idea is package maintainers usually know better about exceptions they need to use. That was one of the design goals of the project, is to give powers in the hand of maintainers. Anyway, what are currently included in the project? First, there is first tool is called youri submit. It's package submission tool. Synopsis is a tool that's in input you give something. Something can be already built binary package. It can be a source package that the tool has to build. It can be a revision number in a versioning controlling system. Then the tool has to extract first the component to build the source package first and to build the binary package. That's input, something. And as output, you want to have a set of validated, meaning controlled, and published package present on the mirror and ready to use for the users. In order to perform the tools run a suite of tests. As an example of tests, for instance, when you submit a new package, you first check that it is really new, and you don't submit an older package. If you have a policy that, for instance, in order to backport some package to a previous version of the distribution, you first have to have at least this version number if the current distribution, you can test it. You can also test that your history, if the history is maintained, it's accorded in the package logs, that the history is still continue. And you have actions. For instance, if you give the tool a revision number, you have to extract the component for the versioning system. You have to build a binary package. If you don't give the tools already built, you have to sign the package if you're cautious. You may eventually archive when you submit a new version of package. For safety reason, you may prefer to keep all versions aside. You may also put files under version control after submission. It all depends on your build system. So that's this tool is just a way to run test and run actions. And action and test have to be coded by project admins. The second tool is youri check, which is a package checking tool, a quality assurance tool. In input, you give it a list of package, and as output, you get a list of report of what package break your different tests. The test can be performed on each package individually. That's kind of RPM lint or lintian lint, meaning, test, meaning does the package pass or fail the test. That can be also a new version of the package. Is this package known to build or not build? That's individual test. You may also have distribution-wide test, meaning are the dependencies of this package satisfied by the others in the distribution? Do this package conflict with other? Or do you have source package that don't have matching binary ones, or the opposite? And you can generate various reports in various formats, such as HTML page. You can send mails to bad packages, and you can have RSS feed or so on. A third component of the project is a library, which is a list of Perl module, but you get basically some stuff to deal with bug tracking system. You get some stuff to manage configuration in a similar way between the tools. You get quite an interesting list of package dedicated to performing various tasks on various package formats, such as automatic builders, automatic generators, and automatic updaters for RPM. For instance, what you can do with the two of this module is automatically update one RPM package, whereas a package with a given version, you can automatically update to a new version, and the code with pass the spec file will automatically extract new version, download it, and update the spec file, and then you can automatically rebuild the package. That's quite interesting and avoid many manual work for the maintainers. You can also, with another module, automatically create a fake package for testing purpose. For instance, you have a tool, RPM lint, that is able to catch typo in description. Or you do test it in an automated manner, for instance, for redirection test. But for instance, you can generate automatically a package, an empty package with nothing inside, with a ugly typo in the description. It is automatically built, and then you can run regular redirection tests with it and ensure that your favorite package checking tools still works. That's this kind of stuff you can do with the module suite. Okay, that's all. There is also some code inside the modules currently that it's not available separately, that could be extracted properly, which will be interesting. We got stuff for comparing version strings. When you pass, for instance, fresh meat page or HTML page, you get all kind of alphanumeric versions, and it's quite difficult to correctly sort the different versions. Of course, The first one is the most recent one, and the three others are perfectly equivalent and semantically, but syntactically they differ. And you have to correctly pass them and order them. It's something that may be useful. Another thing that could be interesting is a possibility to compare package name between different distributions. For instance, that is a Perl package, or in Perl language, a Perl distribution, which upstream name. That's the way that the corresponding package name will be called in Mandriva or Fedora world, and that will be the corresponding package name, in Debian world. And many discussion we have in this discussion room. Typically, we have discussion of how to compare package in different distributions, so as to compare the description first, for instance. And in order to compare stuff, you have first to find what is the same package in different distributions, given that we have different naming policy. That could be interesting to extract, but it's not currently. So, implementation, detailed, and instance. We used Perl, great for many reasons that any Perl lover will agree with, and maybe other too. Perl was perfect for gluing everything in place. But for implementing test itself in pure Perl, it is not a good idea, for instance. For two reasons, readability and performance in some case. Instance, I will try to explain a test that try to assert you don't have file conflict in your distribution. So writing such of algorithm is painful in imperative language. That's an instance. That's in order to check if you have conflict, you have to read all your package, for all package get all your files, and for each files index various metrics about your file, such as the name, the MDSN sum, and so on. And then you have to run your comparison algorithms, which is destroyed by AI and pseudocode. Yes, it's not very readable, and some languages are better suited for this kind of stuff. And apart the readability issue for humans, there are the performance issue for machines. If you get to index every strings, every files that compile that's different shipped in package in a distribution, you have a very large memory footprint, because you have to, for each package and for each supported architecture and for each binary package and for each files and for each file the various metrics you have to extract. That's usually several gigabytes of memory if you do this in pure Perl, which is very large. So Perl was not suited everywhere. Hopefully, not hopefully, but fortunately, we got additional programs to do this check, and you don't have to rewrite them. For instance, there is something very useful which is written in OCaml, which is RPM check, which also exists for Debian world as debcheck, that does all this automatically for you in just a few seconds. Sorry? Yeah. Unfortunately, that's a researcher tool. And another solution is to rewrite some specific part of what you test in other language. That, for instance, you can rely on SQL database or any other kind of database for fast indexing and fast retrieval, which is basically dropping some kind of Perl code and delegating in other language would be a possibility. Some sample of code itself. That's for the submission test. Imagine a test that will prevent employees to work outside of legal work hours. That's a test that is called work inspection. How does it run? First, you get some kind of description and documentation. Then, that usual precaution when you use Perl. You have to derive from the basic test class, and that's very simple. You got to implement a simple method that gets lots of stuff as input, and you just have to compare the current time with the legal time, and if you're running outside of allowed moment, just raise an exception, and you will prevent the package submission to finish. A simple test. Another example which illustrates modularity is how do you retrieve who is maintaining a given package. You can, in this example, use an LDAP server to store the correspondences between people and package. That's a plugin that implements the resolver class, and yeah, there is a constructor method and just a simple method to implement, which is retrieve who is doing what. That's for modularity. You can imagine the same for flat files, for Buzilla, for DBMS, anything. So if your project doesn't use LDAP server for this kind of stuff, you just have to rewrite this part. Work in progress now. The code base is quite old. The project started in 5 years ago, something like that, and it didn't evolve much in the interim. I started recently to adapt to modern Perl guidelines and switching, for instance, to Muse, because Muse rules, to use the DB8 class for data storage instead of ad hoc data model, and to switch to dynamic web page interface, probably using Mason or anything else. But it's currently under rewrite for ease of maintenance. Some conclusions about the experience. It's about QA management and project. QA is basically finding issues, problems. You have several strategies to finding issues. You can try to finding them the earlier at submission time, which is prevent package with non-problems to be submitted. The earlier the better. You can check after submission, and then you're testing that package already used. Various strategy. Once you find problems, you have to evaluate this problem, meaning are they varying their severity? Are they just warning, error, intermediate, anything? And you have also probably to evaluate if they're real issue or if they could be false positive, for instance. That's if you're sure there is a problem or suspect there is a problem. It's all on part of the way that once you know there is a problem, you have to make this problem corrected. And the point is not to be the only guy that correct problem for everyone else, but to have maintainers correct this problem. So you have to keep their motivation high, and the higher the better. So you have to possibly avoid false alerts. If you have a wonderful tool that raises hundreds of alerts every day, the first day people will look at those alerts and eventually correct them. The second day they will ignore them, and the third day they will just blacklist your mail. So you have to avoid false alerts at maximum. You have to use an opt-in approach, which means don't draw people under tons of mails they don't want to. Allow people to either select to receive mail or not, or even better, to either receive mails in different format, or not mails, but receive something else as mail. That's opt-in approach is better than opt-out in general. You have to make your reports clear and readable for everyone, and not just for you, the guy that implemented the test. Possibly explain what's the problem, because not everyone understands them. You have to possibly delegate the ability to maintainers to configure exceptions. And publish metrics, if possible, can be fun, meaning who is doing best. That's kind of emulation. That's for conclusion. I will give some kind of show what is some example. The project as a website, there is a demonstration running online. I will show you it just in a few minutes. And there is a real use in applied to PLF project. So just if network works, I think so. Okay, that's a demonstration of the check-in tool, not the submission tool, applied to Mandriva, which is running daily. There is a list of tests, basically 6 tests running, and that's, for instance, the list of what is package with new version available somewhere else for the whole distribution. So there is a quite huge list. It has been updated this morning at 6 p.m. in the morning. And what, for instance, you can see is, oh, here that GDM, whose maintainer is Fred, is available as a new version in GNOME Upstream project, for instance. What can we see? What can we have? That's various libs. Okay, that's various input source. Debian use a similar stuff, which use per package data, which tracks upstream source. But each maintainer has to enter some kind of regex that says, oh, upstream page for this project is here, and this stuff is running regularly. That's different. Here you browse various sources. That you browse all FreshMeat, you browse all Debian, all Fedora, and then the algorithms try to map it to a Mandriva package and try to compare versions. So it's different. It's running differently. There is a RPM check stuff that for each package. For instance, all the DKMS is quite special, but let's say that what is interesting here, if I try any, KDE. KDE full workspace in main package is broken because it's relying on some dependencies that is not found in the distribution, for instance. Yes. Nepomuk is, not Nepomuk, but Nepomuk extension for Kmail is broken because of a version dependency is missing, and so on. So that's report for various tests for the whole distribution, and I can have sorted by maintainer and to have my own reports and to, in my own case, ouch. That's my own list of broken package, for instance. Or that's my own list of package that doesn't build anymore. And if I follow the link, I will have the build-bot log. Okay, I can have it in other pros format. For instance, that's RSS feed matching the update test. Okay, that's That's finished for the talk. Now I may eventually answer some questions if you have. Yep.
How tight coupled is the youri with the web interface? I mean, web interface isn't the most sexy, and you'd probably want to integrate it better with other other whatever web stuff.
Yeah.
Is it easy to do, or is it like very tight?
Is it part of the work in progress, which is to rewrite this web interface, which is made of statically generated HTML page daily, which is to rewrite it dynamically.
Yeah, okay. Yeah.
But that's work in progress, and I'm not very efficient at this.
Yeah, you need to be able to deploy it and everything, I know. Yeah, because what I'm thinking, like, if you'd like for it to be adopted outside, you want something that can be easily integrated with what's in, well, what you people are already using, and just not taking this and try fit it in, and it doesn't look as sexy as the rest.
But basically, I know what to do for the technical part, which is how to implement. What I need is input at what to how to design the web interface for users.
Well, you know,
and I search.
You know, I have some ideas for you that probably might get in there sometime soon, I hope. But yeah.
Do you have an example of uploading a package? Like,
you want a real example? I may try. Unfortunately, what I could show is the way we use it at Mondriva, but it's embedded in other part of the build process, meaning we don't call youri submit directly. It's embedded in another tool that is very specific to Mondriva. So unfortunately, I cannot give a demonstration right now.
So, what does it look like? I mean,
it's ugly command line stuff. When you give it a command and you give, please upload this package for a cooker, and then the tool just reply nothing if everything works, and if something fails, for instance, you don't have the right package release extension for the project, your package is rejected. Please try again.
All right. So also, if you try to upload a package and there's a library missing or so, it just refuses to upload it.
If you have the test for this.
All right.
Basically, the tool itself is just something that reads a configuration file. Mm-hmm. The configuration says, oh, run. Then it runs this list of actions.
Yeah, okay. Cool.
Yes? Yeah, but thank you for your attention.